Well, hello students, welcome to this class with me, Mr. Alfie. And this is mathematics class. In this particular video, we're going to learn about discriminants and quadratic graphs, and also relationships between the roots and the coefficients. This is the general form of quadratic equation. We can predict the graph. If a less than 0, that means a negative number. So this is a possible graph. You can see here, the vertex becomes maximum point and the graph open downward. If the value of a greater than 0, that means a positive number. So the vertex in this graph becomes the minimum point and the curve open upward. So this is the summary. If a less than 0, the curve opens downward and the vertex becomes maximal point. If a greater than 0, the curve opens downward and the vertex becomes minimum point. X-intercept is actually the roots of quadratic equation. So for this quadratic graph, the root is this point, alpha and beta, because alpha and beta is the intercept in this axis, x-axis. So the relationship between quadratic graph and discriminant. If discriminant greater than 0, that means the quadratic equation has two distinct roots. So this is the possible graph. But in this particular graph, the value of a greater than 0 because the graph opens upward. In this particular graph, the d is still greater than 0. There are two roots, but the a less than 0 because the graph open downward. So how about d equal to 0? If the discriminant equal to 0, that means the quadratic equation has two identical roots or one root exactly. So in this particular graph, the value of a greater than 0 because the curve open downward, and in this graph, the discriminant still equal to 0, but the value of a less than 0 or negative number because the curve open downward. How about the d less than 0? The discriminant less than 0, that means the quadratic equation has no real roots. That means there is no x-intercept. There is no x-intercept here. So in this particular graph, the value of a greater than 0 because the graph open upward. In this graph, the discriminant still less than 0, but the value of a less than 0 because the graph open downward. Now we're going to learn how to make a quadratic graph of the form y equal to a multiple with square of x minus h plus k. As we know, this is a standard form of quadratic equation, y equal to ax squared plus bx plus c. We can change this into the vertex form. This is what I call vertex form. y equal to a multiple with square of x minus h plus k. So how to find the value of h and k here? As you know that a, b, c, this is from the original equation. So the value of h can be found by negative b over 2a. So after we found the value of h, we can find the value of k. The value of k is actually, you need to substitute the value of h into original equation. So after you find the value of h, you substitute h into this equation. So this one, k equal to f, the function of h. This is the function. So let's jump to the example. Sketch a quadratic graph. So the equation is y equal to 2x squared minus 10x plus 12. From this equation, we know that the value of a equal to 2 and the value of b equal to negative 10. So first step, we need to find the value of h. The formula of h equal to negative b per 2a. We know that b equal to negative 10, so negative b is negative of negative 10 per 2a. 2 times 2 because the value of a equal to 2. So it is equal to 5 per 2. Now we're going to find the value of k, the second step. So we find the value of k when we substitute the value of h into the equation. This is the original equation. So substitute the value of x equal to 5 per 2, where 5 per 2 is the value of h, to the equation 2x squared minus 10x plus 12. So you will find the value of k equal to negative 1 per 2. Okay, substitute the value of h into the original equation here. This equation, you find the value of k. So this is the vertex form. Y equal to 2 multiplied with square of x minus 5 per 2 minus 1 per 2. Remember, this is the vertex form. A, the value of A is 2 from the original equation, and then x minus h. So the value of h equal to 5 per 2, and the value of k is negative 1 per 2. So the vertex is actually the coordinate of vertex is x comma y, where x is the value of h and y equal the value of k. So the coordinate of the vertex is 5 per 2 comma negative 1 per 2. From here, this is the value of h and this is the value of k. After we find the value of the vertex, now we're going to find the x-intercept. In order to find the x-intercept, we have to assume that y equal to 0. So this is the equation. Substitute the value of y equal to 0 in this equation. So it becomes this equation. 0 equal to 2 multiplied with square of x minus 5 per 2 minus 1 per 2. So we move negative 1 to this side, it becomes positive. So we divide each side with 2. So it is become this equation. Okay, this one divided by 2, it's 1. This one divided by 2 is 1 per 4. So next, look at this both sides. We square root both sides. So let's become this one. This is square. We make a square root of square. It disappear the square, and this is x minus 5 per 2 equal to plus minus square root of 1 per 4. Next, we know that the square root of 1 per 4 is plus minus 1 per 2. We are going to find the value of x. So x equal to 5 per 2 plus minus 1 per 2. So when it is positive, so x equal to 5 per 2 plus 1 per 2. So when it is negative, so x equal to 5 per 2 minus 1 per 2. So the value of x 3 or 2. Now we're going to state the coordinate. So the coordinate of x-intercept is 3, 0 or 2, 0. So this is the value of x from our calculation, and the value of y here. Value of y from here, from the assumption that we have made before. So 3, 0 and 2, 0, x, y. Next, we're going to find the y-interception. In order to find the y-intercept, we need to assume that x equal to 0. So substitute the value of x equal to 0 in this equation. You'll find this equation. You can see I substitute the value of x into 0. So by calculating, you will find that the value of y equal to 12. So the coordinate of y-intercepts is 0, 12. 12 comes from this number that we have calculated before, and y and x equal to 0 comes from our assumption before. So after we found the vertex x-intercept and y-intercept, we put those points into the coordinates. This is the y-intercept, this is the x-intercept, and this is the vertex. Next, we connect all that point and we'll make the quadratic graph of y equal to 2x squared minus 10x plus 12. Whereas this is the vertex, and the coordinate of the vertex is 5 per 2 comma negative 1 per 2. As you can see here, the value of a greater than 0, positive number, that means the curve open upwards and the vertex become the minimum point. Forming a quadratic equation with given roots. So this is a general form of quadratic equation: ax squared plus bx plus c equal to 0. So by ABC formula, the root is negative b plus minus square root of this discriminant per 2a. So for the first discriminant, this is the positive, so negative b plus square root of d per 2a. For the second roots, negative b minus square root of d per 2a. Let's say the first root equal to alpha and the second root equal to beta. So alpha equal to negative b plus square root of d per 2a, and beta equal to negative b minus square root of discriminant per 2a. So if we sum the root, the alpha plus beta equal to negative b plus per a. So if we multiply the root, alpha multiplied with beta, so equal to c per a. This is the product of the root. So the new quadratic equation is x squared minus, so for the coefficient of x is the sum of the roots, and for the c is the product of the roots. Let's jump to the example. The example from a textbook, page 38. If alpha and beta are the roots of the equation 4x squared plus 6x minus 9 equal to 0, find the value of each of the following: a. alpha plus beta, and b. alpha beta, or alpha times beta. Remember, this is the quadratic equation. So we know that the value of a equal to 4, the value of b equal to 6, and the value of c equals to negative 9. Remember, for the sum, the formula of the sum of the roots is negative b per a. So it is equal to negative 6 per 4 because b equal to 6 and a equal to 4. So the value of a plus b equal to negative 3 per 2. For b, alpha times beta, the formula is c per a. So equal to negative 9 per 4 because c equal to negative 9 and a equal to 4. Next example. If alpha and beta are the roots of the equation 3x squared plus 7x minus 1 equal to 0, find the quadratic equation with the roots 2 alpha plus 5 and 2 beta plus 5. So this is the first equation, 3x squared plus 7x minus 1 equal to 0. So the sum of the roots of this equation is negative b per a. From this equation we know that the b equal to 7 and a equal to 3. So the sum of the roots, alpha plus beta equal to negative 7 per 3. So for the product of the root, alpha times beta, the formula is c per a. We know that c equal to negative 1 and a equal to 3. So alpha times beta equal to negative 1 per 3. So the sum of the new root is 2 alpha plus 5 plus 2 beta plus 5. Come from this one, from the equation. And we can make it as 2 multiple with alpha plus beta plus 10. This is the sum of the new roots. We know that alpha plus beta actually negative 7 per 3. From here, we substitute the value of alpha plus beta, negative 7 per 3. We got from here, so 2 times negative 7 per 3 plus 10. So it is equal to negative 14 plus 3 plus 10 equals to 16 per 3. This is the sum of the new roots. How about the product of the new roots? So this is the root, and also this is the root. So we multiply this one, 2 beta times 2 alpha times 2 beta, 2 alpha times 5, and then 5 times 2 beta, 5 times 5. And we'll get 4 alpha beta plus 10 alpha plus beta plus 25. And then we know the value of alpha times beta, and also we know the value of alpha plus beta. We substitute the value of those number. So 4 times negative 1 per 3 plus 10 multiple with negative 7 per 3. This is the sum of the product, the sum of the roots, plus 25. So it is equal to 1 per 3. Remember, the quadratic equation with the roots 2 alpha plus 5 and 2 beta plus 5 is this one. X squared minus the sum of the roots x plus the product of the roots. Remember, the coefficient of the x is negative of sum of the roots, and the c, or the constant, is the product of the roots. So we have found the sum of the roots and the product of the roots. We found the sum of the root is negative 16 per 3 x, and then the product is 1 per 3. So we times this equation with multiple 3, and I will got 3x squared minus 16x plus 1 equal to 0.
I think that's all for the matter, and thank you so much for watching this video. Don't forget to do your assignment edit module and submit it on time. Keep the spirit up and stay healthy. Bye for now.